Hi guys, in this particular short video I'm going to show you on how we're going to write Verilog code for the slow clock. Okay, let's say in a FPGA board that we have like a 50 megahertz, how we can slow that clock so that we can drive it, let's say, to blink the LED. Let's say if you want to blink the LED for every 1 second, so you must create a counter such as it's going to count for 50 million time or 50 mega, then only the counter going to be equal to 1. Okay, if you want to test your code on the test bench, it's hard for you to create like a 50 megahertz, because 50 times 10 to the power of 6 is quite huge, right? So let's say we create a clock that we can it is visible on the test bench, okay, during the slow time period. Then after that you can modify the same value for the higher value. Okay, let me try to show you first, and maybe you can get the idea from here. Let's say my input is clock, okay, then the output is a slow clock. Okay, so the input going to be the clock, all right, then the output register slow clock. All right, then I'm going to create a few integer I. Okay, all right, so now I'm going to clear first my integer, so I'm going to create an initial block, initial begin, let I equal to 0 first. Okay, I also want to clear the output, so let the output initial value is supposed to be 0. SLK, so equal to 0 first. Okay, and then I'm going to create a counter here, so create an always block, always at positive h, CLK begin. Okay, let's say I want to create a slow clock, let's say for only 10. Let's say for every 5, every time it count to 5, then the slow clock become 0. Every time more than 5, less than 10, it become 1. Okay, so if I equal to 10, so then the I going to reset become 0. Okay, else I want the I keep counting equal to I plus 1. All right, so in this particular always block, the I going to keep count until 10, then after that you're going to reset, then keep continue counting. So now here I'm going to define the slow clock, always create another always block, always add still positive h clock. Okay, then begin. Okay, here what I'm going to do, I'm going to create a condition. If say I less than 5, okay, then my slow clock going to be 0. Okay, else if I more than or equal to 5, so now I'm going to be, now I'm going to drive the slow clock equal to 1. All right, that's all. As simple as that. We want to create a simple model first. Okay, now for this particular block here, we create a counter for the I. Now we create a condition for the I. Let's say if I less than 5, we want the slow clock become 0. Else if I more than or equal to 5, okay, then slow clock become 1. Okay, save this file, then add one test bench file. Okay, okay, as for the test bench, we want to create only the clock, so we can create clock as in forever for every 2 nanosecond, clock going to toggle, not clock. Okay, as simple as that. Save. Now you're going to simulate. There you go, you can see what's going on there. So you already create one slow clock. Okay, this is the first, this second line is for the clock, and the above line is for the slow clock. So you already divide the clock that we have. Let's say in the board we have this higher frequency clock. Now you have slow down the clock by create a counter. So if you can see from this particular program just now here, we already create one counter. Let's say now our task is to modify this. Let's say in the FPGA board we have a 50 mega, right? So now we can create 100 mega, so that every time 50 mega it become 1, another 50 mega it becomes 0. So 100 mega, 100 mega, 1 2 3 4 5 6. Then we have here 50 mega, 1 2 50, 1 2 3 4 5 6. Just go to copy this line and paste here. If I write the code like this, it's going to be very hard for me to view from here, right? So that's why just now initially I create just for the count for the 10. Then once I verify my code is working, then I changed back to the 100 mega according to the question in the laboratory, okay, in the lab and the manual. All right. So let's say if you want to test this code, let's say if you want to divide into 2 only, let's say instead of 10 I put only 2. So here every time 1, 2 is too slow, right? Let's say just now here, this particular example here for 10. Now we have here for 6. Then every time 3, okay, less than 3, then more than 3. All right. Now you can see the difference here. We can count is for the 5, right? So let me close this one first. This one initially the period. Okay, the total count for the 10. So 5 for the count of 5 is 0. Another 5 is going to be 1. Okay. Now I change to 6. Try to save the file. All right. Try to see what is the error. Okay, I'm sorry. Close the bracket. Okay, save. Okay, now simulate. Okay, now you see much shorter period. Okay, let's say if I want to change to 20, it's going to be more longer. I can change to 20. So one period for the 0 is going to be 10. Another period for the 1 is going to be 10. So save the file. So you can see the timing diagram for the slow clock. There you go. You can see. Now we are make it more slower. Okay, we want to bring the frequency so down slower, so that we can see, let's say, a blinking LED for 1 second. So let's say if you have a 50 megahertz, you want to make it 1 second, so you have to count to 50 50 times 10 to the power of 6. All right, hope it's clear and hope it's helpful. Thank you guys.